Consider the two diagonals on a standard multiplication grid. If you were to multiply all the numbers in one diagonal together, which of the diagonals would have the greatest product? Okay, so hopefully you've had a chance to try this task then, and you've come to the nice realisation that actually both diagonals have exactly the same product. Now I'm interested in how we got there. Now it may well be in the first instance that you just grabbed a calculator and you discovered that the product for each of diagonals is this rather large number here. But could we play this a little bit more cleverly? Could we use prime factorisation, for example, to arrive at the answer that both products are the same without necessarily working out what this product is? Okay, so if we can find the prime factorisation of all the numbers in one diagonal and compare it with the prime factorisation of all the numbers in the other diagonal and show that they are the same, that's enough to show that they both have the same product. So I guess the first question is which primes are we going to need to form all of the numbers in these diagonals? And hopefully with a bit of reasoning you can realise that we actually only need the first 4 prime numbers. We don't need to use 11 because it's a 10 by 10 multiplication grid, so none of these numbers are going to be in the 11 times table, so we don't need to use 11. Okay, so let's do kind of like a tally to keep track of all these then. So we don't need to do 1, obviously. If I'm doing the green diagonal here, we don't need to do 1. So let's start with the 4, which is 2 times 2. And then 9, which is 3 times 3. And 16, which is 4 times 4. So that's another 1, 2, 3, 4 2s. 25 is 5 times 5. 36 is 3 times 2 times 3 times 2, 6 times 6. So 3 times 2 and 3 times 2. And then we're up to 49, which is 7 times 7. Then 64, which is going to be 8 times 8. Now 8 is 2 times 2 times 2, so a whole load of 2's here. So we've got 2 times 2 times 2, which is 8, and 2 times 2 times 2, which is another 8. Then we've got 81, which is 9 times 9. So it's got 3 and 3, 9, and another 3 and 3, which is another 9. And then finally 100, which is 2 times 5 and 2 times 5. So I've kind of done like a tally chart where I wasn't keeping track of the gates because it was just too hard to do that mentally. But essentially this is what we've ended up with, how many of each prime factor. So let's counting up the 2's, we get 4, 8, we've got 16 2's, we've got 8 3's, 4 5's and 2 7's. Now let's do the other diagonal now. So we've got the blue diagonal. So hopefully when I do this we'll end up with exactly the same. Fingers crossed. So 2, 3, 5 and 7 again. Right, starting with the 10's, so that's going to be 2 times 5, the top right corner. Then we've got 18, which is 9 times 2, so that's 2, 3 and 3. 24, which is going to be 8 times 3, so 1, 2, 3 and a 3. And then we've got 28 now, which is 7 times 4, so 7 and 2 more 2's. And then 30, which is 6 times 5. So we've got a 5 and a 6, which is a 3 and a 2. Now something quite nice happens here. I've just noticed that these numbers now just repeat themselves. So I've got all these numbers here, but it's just going to be double of all these because the rest of the diagonal is just a repeat. So how many we've got so far? We've got 1, 2, 3, 4, 5, 6, 7, 8, which is nice because I need to double it now and get 16. I've got 4 3's. When I double it, I'm going to end up with 8. Going to end up with 4 5's and then 2 7's. So you can see we've used exactly the same prime factors to make the 2 diagonals. And you could also, I guess, link this to ratio tables as well. I guess if you just consider the outer square, the outer square numbers, you got 1 times 100, which is obviously 100, and 10 times 10, which is 100. Then if you move in a little bit, you've got 4 times 81 and 18 times 18, which all of these have the same products because ultimately the whole multiplication grid is just one giant ratio table. So hopefully that's given you some ideas to behave mathematically, linking prime factorisation with ratio tables. And it's just a lovely task to get pupils practicing prime factorisations of a number, but with a purpose here.